Hey, math friends. So our learning target today is that I can solve one-step and two-step inequalities. So we just talked about what an inequality is. We've talked about what an equation is, and so we're going to talk about how do we solve one and two-step inequalities. So it's just like you solve one-step equations almost. So what does almost mean? So if we talk about solving inequalities and we talk about the idea of if we're comparing 8 and 2, if we compare 8 and 2, we would say that 8 is greater than 2. And that's a true statement, right? 8 greater than 2. Well, if I were to add 2 to both sides, is it still true? Is it still true that the left side is greater than the right side? Yeah, that's true. So if I take 8 and 2 and I add 2 to both sides, the statement 8 greater than 2 is still true. It just becomes now 10 greater than 4, but the sign is the same, still greater than. So if we take that same idea of 8 greater than 2 and we subtract 2 to both sides, is it still true that the left side is still greater than the right side? So we would have 6 greater than 0. Is it still true that if I subtract 2, that the left side is still greater than the right side? Yeah, still true. So what if we take 8 and we divide it by 2? Is it true that 8 divided by 2, I don't know why I just did that. Let's go back to this first step. I got ahead of myself a little bit there. The statement was 8 greater than 2. So we've tried add to both sides to see if anything affects the sign. No effect there. We subtracted 2 to see if anything affects the sign. So now let's divide by 2, left and right, to see if anything affects the sign. 4 greater than 2. Did anything affect the sign when we divided by 2 to both sides? Nope. So let's then take 8 greater than 2, and now let's multiply by 2 to both sides. 16 greater than 4. Did that have any effect on the sign if we multiply both sides by 2? Nope, no effect. So why would I spend my time doing this? We added 2, subtracted 2, divided by 2, and multiplied by 2 when we had no effect on the statement 8 divided by 2. I need space here, so I'm going to erase. So what happens, though, if we get some negatives in there? Let's see what happens. So we're going to take that same statement now, and we're going to talk about a negative. So 8 greater than 2 was the statement we've talked about. So far, there's been no effect through addition, subtraction, multiplication, division of 2. But what happens if we divide by negative 2? Negative 4, negative 1. Is it still a greater than sign? Is it still true that the left side is greater than the right side? Is it true that negative 4 is greater than negative 1? No. So when we divide by a negative, what actually ends up happening is the sign has to flip. That's what we mean by almost. So there's only one other scenario where this happens, and that's why I'm going through this big analogy, is if we take that same statement, 8 greater than 2, and if we multiply both sides by negative 2, is it still true that the left side is greater than the right side? Is that still true when we multiply by negative 2? Is it true that negative 16 is greater than negative 4? No. Not true. So again, this is a scenario where the sign flips. So if at any point you divide by a negative to both sides, or you multiply by a negative to both sides, you have to flip the sign. That's what we mean by almost. Okay, let's go do it. So first problem. We're looking to only flip the sign if we multiply or divide by a negative. So that's kind of the idea of solve one two-step equations. So build house, build fence, clean yard, clean yard. Same old thing we've done forever. We're going to add 3, copy, paste. So we end up with x is less than -1. So now the question is, did I multiply or divide by a negative? No, I just added 3. So then I don't have to worry about flipping the sign. We're going to do super fast graphs on this. So the -1 goes in the middle. We have an open circle at -1. And we're talking about all the numbers that are less than -1. So we're going to talk about all the numbers that are less than or smaller than -1 would be -2, -3, and so on. So we're going to shade to the left. Reminder, open circle here because it's just a less than symbol. So we did not have to flip the sign here. Next problem, build house, build fence, clean yard, clean yard. So here's our house, clean our yard. We're going to subtract 8, copy, paste, copy, paste. Now on the left-hand side, we have -16. Drag sign down, drag it down, drag it down, drag sign down. So far, have I multiplied or divided by a negative at all? No. I just subtracted 8 both sides. Then I don't have to worry about flipping the sign. Now to graph this, I'm somebody that needs to have the variable on the left. So I'm going to take this entire statement, I'm going to flip everything in the statement, which means it's going to become greater than. I'm going to put a -16 in the middle. And one bigger than -16 is -15, because we're talking negatives now. And because this equal to bar on the bottom, I'm going to shade that circle in at -16. And we're talking about all the numbers that are greater than -16. So close circle at -16 and all the numbers that are greater than. So that's our first 2 problems of how do we combine some of these skills that we've talked about before with inequalities and solving them and also graphing. All right. Let's try 2 scenarios here, and I got to be careful about both of these because they're a little bit different. All right. Let's take a look at the one on the left. Build house, build fence, clean yard, clean yard. We divide by 4, copy, paste, copy, paste. Pause. Did I divide by a negative to both sides? No. I see there's a negative in the problem, and I am dividing, but did I divide by a negative? I'm going to highlight what I mean. Did I divide by a negative to both sides? No. I divided by a positive. Then do not flip the sign. 4 divided by 4 is 1. We get x is less than or equal to -4. Do not flip the sign because we did not divide by a negative to both sides. So at -4, we have a closed circle. Why? Because this little bar is underneath it. And one bigger is -3, and one smaller is -5. And we're talking about all the values that are less than -4. So all the values that are less than -4 would go this direction, -5, -6, -7, and so on. So that is our value of how we graph and solve. If I'm going too fast, pause the video at any point, rewind it, watch it again, stick with it. This is your journey. You can do this. Reach out for help if you're stuck. Next problem, build house, build fence, clean yard, clean yard. We're going to multiply nice and high, copy, paste, copy, paste. And when we do that, we get 1 here. Pause. Did I multiply or divide by a negative with an alligator problem? Yeah, I multiplied to both sides by -2. In an alligator problem called an inequality, you have to flip the sign. We proved it on that previous page of that you have to flip the sign or the inequality is wrong. So we get x equals -6. So notice you flip the sign when you multiply or divide by a negative. So that's something we're going to practice today. So we have a -6 here, one smaller, one bigger. This time it's going to be an open circle at -6 because we don't have that bar underneath. It's just a less than sign. We're talking about all the numbers that are less than -6. So shade to the left, to the left, to the left, to the left. All right, all right, all right. Let's try two more here. We're at 10 minutes. We're going to try two more. Now, these are two-step equations, so they're a little bit bigger, but you've been through this process before. So we're going to build house, build fence, clean yard, clean yard. So we're going to add 3, copy, paste, copy, paste. Now, if you need time to write down the problem and stuff, that of course you do, right? Because I'm just moving from problem to problem, which is the why you should just be pausing the video whenever you need to. When I start a problem, I already have it on my screen, but you just need to write it down. Drag it down, 0. Now, if I tug of war that, we get 1. Pause. Have I multiplied or divided by negative yet? No. So I don't have to flip the sign. Multiply, nice and high, copy, paste, copy, paste. So that means that these problems right here, they turn out to 1. We get x is greater than or equal to 2. I do not need to flip the sign anywhere because nowhere in there did I multiply or divide by a negative. So I'm going to put a 2 in the middle. We're going to do a closed circle at 2. And we're talking about all the values and we're going to that are greater than 2. Shade in at 2 because the equal to and all the values that are greater than 2. Hang in there, you guys. I know this is a long one, but this is a super good skill of being able to combine a lot of big things in mathematics, inequalities and solving and graphing and how to know when it's an open circle, a closed circle, when do you flip the sign, all that good stuff. All right, build house, build fence, clean yard, clean yard. Reminder to take that Jersey sign with us. We're going to subtract 9 as our first step, copy, paste, copy, paste. I do not have to worry about flipping the sign yet because I have not multiplied or divided by a negative. So I get 5. I can't get the pen to write. Maybe if I switch colors. Nope. I'm not sure why. There's a little fussy part on the board there. All right. Then drag down, pause. No flip of the sign yet, so we're good to go. The next step then, I'm going to get rid of that -5 through division, copy, paste. Uh-oh, I just divided by a negative to both sides. When that happens, we have to flip the sign. -1 is on the left. X is on the right. I did solve, I did finish, and notice the sign got flipped in that process. So we have a -1 in the middle. We have a -2 that's smaller, and we have a 0. Now, I'm somebody that likes to have the variable on the left, so I'm going to flip everything here. X goes on the left. I'm going to flip the sign. I'm going to flip everything. Open circle at -1 because it's not equal to, and we're talking about all the values that are greater than -1. Good work, good work, good work. So now, this page here, I'm going to have you try, whoops, I'm stumbling there. Just the one on the left. We'll deal with the other one on the right later, maybe. Just the one on the left. Go ahead and give that a shot. Actually, that one's a little tricky, so I might skip that one for now. Might skip those for now. Let's have you solve, yeah, this one. You might probably need a calculator for that one. So if you have a cell phone or something that has a calculator in it, that would be good. And then I'm gonna have you solve that one as well. That one of them might come out as a decimal. I just grabbed my cell phone to solve it. So just be aware of that. All right, so pause that video, try those two. Make sure you have a calculator nearby because you're gonna probably need some help on those numbers. All right, you should have paused the video, so I'm gonna go through and solve these now. So this is after you've solved. Now this is your journey. You should actually be trying these. Plus, I should be seeing your notes anyway. We're going to multiply nice and high, copy, paste by -1.5. When I do that, you should be like, oh boy, I just multiplied by a negative both sides. That means the sign switches. Now I'm going to grab my handy dandy calculator here and multiply that in. So that's 1.5 times 7 is 10.5, and that would be positive 10.5. So just because of the decimal, I put that in the calculator. Now, I'm not somebody that can graph that very well, so I'm going to take the entire quantity and flip that. and then I'm going to graph it. And I'm going to go a little different version on the graphing here. I'm going to put 10 here and 11 here, which means that 10.5 is actually in the middle. So see how I did that? I put the integers on the outside, and it's a closed circle because this bar that's under here. And we're going to talk about all the values that are greater than basically $10.50 if we think of that imaginary placeholder, $10.50. So there's our first problem of you try. Let's see how you did. So make sure that you have checked that your sign is correct, that the graph is correct, and so on. All right, next problem here. Build house, build fence, clean yard, clean yard. So we're going to subtract 9, copy, paste, copy, paste. If I haven't used it, drag it down, drag it down. And we end up getting 93 minus 9 is 84. Looks like we might get a decimal here, huh? All right, so do I flip the sign yet? Nope, we're just subtracting, so we don't have to worry about it only when we multiply or divide by a negative. So the next step then is going to be divide by -8, copy, paste, copy, paste. Division here. Uh-oh, divided by negative on both sides, so I have to flip the sign. And when I do that, what am I going to end up with? Like 10.5, I believe. Yep, negative 10.5. Okay, so very similar style graph here. So I'm going to put a -11 here and a -10 here, and negative 10.5 would be halfway between. We're going to do a closed circle. And we're talking about all the values that are less than negative 10.5. So we're going to shade to the left. All right, so that is our solve and graph each inequality situation. Lots of good math stuff going on here. I am actually going to skip the add subtract ones, and let's just do one of these. I think we're going to do this one. All right. 10 minus 1/2 of a number is less than 20, is what that statement says. 10 minus 1/2 of a number is less than 20. All right, build house, build fence, clean yard, clean yard. Now we could kill that denominator first here, but I don't think we need to because it's just a fraction, 1/2, it's pretty small. So I'm going to subtract 10, copy, paste, copy, paste. Build my house there. Drag it down, drag it down. All right. So now, first step is to kill the denominator. So when I go to kill the denominator, I'm just going to multiply nice and high, copy, paste, by the value of 2, just to kill that denominator. I said I wasn't going to do that, but I ended up doing it anyway. That leaves me with negative 1x is less than, oh boy, I can't get the pen to write, is less than 20. I'm not sure why. Is less than 20. Now, I did multiply by 2 to each side. So if I highlight that, you'll notice that I did multiply by 2 to both sides, but I did not multiply by -2 to both sides. So I do not have to flip the sign yet. Maybe I won't have to at all, but yet. Next step then is to isolate the variable x, divide by -1, copy, paste. And when I do that, I get that x, because I just multiplied or divided by a negative to both sides, I have to flip the sign. So I get x is greater than -20. So here's -20. Here's -19. Here's -21. So we have an open circle at -20, and we're shading to the right. So that's how we would take a situation and be able to convert it into an equation and then solve really an inequality. So we're almost at the 20-minute mark, and I have a lot more problems to do, but I'm not going to keep you hanging on that too long. But that's the idea of how you do that. So last little summaries of the day, just a reminder about graph that we only flip when we multiply or divide by a negative. And the key is that we're doing that to both sides. Not if a negative is in the problem, but if you multiply or divide by a negative to both sides, then you have to flip the sign. All right, have a glorious night. Good